Welcome to this web lecture that deals with the usability principle of handling errors. Now, in most cases, errors should not be handled at all because they should not appear. This screencast will illustrate that.
In this screencast, I will show how the OASIS system used at our university deals with errors. I am currently logged in as Natasha Stash, who teaches a course on web technology. And we're going to try to add an announcement to this site. We do this for the academic year 2014-2015. You might think I need to filter the search here, but actually I have to do that further down on the same screen. This is a problem with error prevention, right? I would normally first do the wrong thing. Here's a site, 2ID60 web technology. I'm going to open it and I get an error. The error says access denied. Now, if there is one person who must have access to the site, it is the teacher of the course. So this error is in error and we need to get rid of it. The most obvious way to do that, given that we have a pop-up box, is to look for an X. It is there. I click on the X, the error should go away. I click, the error stays. Let's try again. Error still stays. There doesn't appear to be anything helpful here, so I will try to get help, which will appear in a new window. The help again gives me access denied. There is one more thing I can try, which is the general help that the system supposedly offers. I will click on help. Nothing happens. Final conclusion, this system is unusable. We are never going to use it again.
There are mainly two types of errors, of which we in fact have seen the first one, which is that the system does something wrong. Frustration is almost guaranteed when you try to do the right thing and the reaction of the system is just completely wrong, like getting an access denied for something you should have access to, or when the system crashes even though the hardware is still intact. It's difficult for such errors to find the right way to tell the user that it is the system's fault and we are sorry that this happened. The second type of errors is when the user does something wrong. Now, in most cases, the user does something wrong because of confusion. The user gave the wrong command because he didn't know that it was wrong. So the messages should clearly explain what happened. It should not condemn or ridicule the user, but offer a solution. Here is an example that shows the problem of dealing with errors in an honest way. This fictitious application word wonder has unexpectedly quit due to a type 2 error. This is, of course, a lie. Applications do not quit unexpectedly. Everything that can happen in a computer should be expected by its programmers. When you try to write a file, this can go wrong. You should check whether opening the file works, whether the disk isn't full, and make sure that if you give a message to the user, it explains what is going on and offers the way out, but never say, oh, we unexpectedly quit. You could say, well, the application has quit. Yeah, we were not surprised because we are sloppy programmers, but that, of course, doesn't generate a good feeling with your users. There are researchers that think that computers should emulate human etiquette and therefore say that they are sorry. The problem with this is that no one really believes that the computer has a human mind and really feels sorry. Would you be forgiving when the computer would say, oh, I'm really sorry I crashed. I'll try to not do it again. Yeah, right. When the computer doesn't try to not do it again, right? They're just bad programmers that create this, right? We don't believe when the computer tries to pretend it is human and will try to do its best. Another problem is that we often see codes. And because of these codes, we get to know what they mean. You probably know what error 404 means. It means that on a website, you try to access a page and that page does not exist. It's not found there. And maybe you also know error 401, which says that you must provide authorization. Although this is less likely, the browser may capture this error and then show you a dialog box so that you can try to get authorized. There is another message, error 403, that says that access is forbidden. In these three cases, to some extent, you did something wrong. You tried to access a page that wasn't readily available. Maybe it's not available at all. There are other messages that you probably also know. An example is error 500, internal server error. This is a case where it's clearly the system's fault. And it could have said, sorry, at the moment there are more users than the programmers anticipated and we cannot handle them. Please try again later. Right? Make sure the user understands that the system is at fault. The user did nothing wrong. When something goes wrong, we should help the users in solve the problem. The error message should first of all tell you what's wrong, where did it go wrong, what can you do to solve this. A nice example of a meaningless error message is that the network cable is unplugged of a wireless Bluetooth network. The system has detected that the network doesn't work, and it has generalized from a situation of cabled network and gives the wrong error message. In some cases, error messages are ridiculing the user. This road sign is a nice example. Most likely, the user is trying to be on Highway 89. Maybe the user was on Highway 89. Something happened which many users encounter, and they end up on a road that is not Highway 89. It doesn't really help to mock the user, oh, this is not Highway 89, and then not tell you how to get back on Highway 89. The place for error messages is also important. The main principle is to always place error messages where the user is looking. The Oasis screencast clearly showed a good example there. Even though the message should never have happened, it was placed in the center of the window so that you couldn't miss the error message. Sometimes we are forced to follow a standard that says where error messages should appear. And sometimes that is not the best possible location, but at least when it's standard, users can perhaps expect them to be there. Now, sometimes an error can be grave and require urgent attention by the user. A good example of how this can be handled can be seen in the science fiction series Star Trek. Sometimes there is an imminent danger. They call it a red alert. And there is a siren that goes off. Woo, woo, right? And the lighted back panels all light up in red. And the good thing they then do is that after a very short while, the siren goes off. Because the users need to have silence so that they can discuss how to get out of this difficult situation. Now, of course, in the TV series, they mainly turn off the siren so that the spectators can hear what the actors are saying, right? But it's a good principle nonetheless. Also important is to not make it look worse than it is. Errors are very rarely fatal. Not many users get killed because of an error of the system. And when you're typing some input, there's no reason to shout that it is wrong. The use of all caps in computer speak is the equivalent of shouting. We should never use all caps in error messages. We should adapt the language to the user or the circumstances in which we encounter the error. Here's an example. Something goes wrong, and we can have a friendly chat with our user, Chris, saying, "No, this isn't right, you can do better, try again." In a learning application used by young people, this may be acceptable. If adults are trying to learn to use a system, we are happy to see incorrect, try again. So the wording should really be adapted to the situation. There is a difference in how you would perceive the system depending on this type of message. And you can think of why you would prefer which type of message under which circumstance. We should also help users to recover from the errors. And first of all, when we are typing something, we will sometimes make a mistake, and we use the backspace key to get out of that. We call this correcting during input. Old computers used separate terminals and a backend mainframe, and on the terminal you would type a whole line of text which would be sent to the computer when you hit enter. So when you're correcting something on this line, the computer hasn't yet seen it, so it's corrected during input. With modern computers, that's no longer the case. Everything you do is processed by the computer. We can correct directly after input using an undo function. And we can try to correct at a later time. There are very few systems that make it possible to undo an old operation without having to redo all the steps that follow. What is more likely to be available is to have versioning, so that when you find out that you completely screwed up a version of the file, you can say, no, forget everything I did. Let's go back to the previous version. You should also allow an undo across application boundaries, so that it doesn't matter, for instance, that you save, right? The undo should still apply to everything you did before. In your final project, you are going to create a relatively simple interface that will be used by users who are not going to study documentation. They're going to try things, and you must make sure that there are never any grave consequences, and that whatever they try, they can always undo. Thank you for participating.